Welcome. I'm just going to give you some quick instructions on how to do the elevator lab. So you're going to be starting in the physics classroom web page with this little interactive, all right? You're going to launch the interactive and then resize it till it's a reasonable size, okay? And what you see here is we have a person sitting in an elevator. Now, normally in this lab, I would have you really sit back and imagine the feelings that you have when you're in an elevator, right? There are times you feel heavier than normal. There's times you feel lighter than normal. There's times you feel normal. I, for one, have not been in an elevator in at least a year, because quarantine. But we will be riding elevators again. So imagine you're sitting in an elevator, right? And there's downward force of gravity on you, but you don't plummet to the center of the earth, accelerating with your force of gravity, because there's also a force counteracting that. And that is, as we're going to learn, that's called the normal force. So the normal force is a name for any kind of supportive force when you're on a surface. So if you're standing on a floor, if you're sitting on a chair, the chair is providing a normal force to you. Even if you lean up against a wall, right? Okay, then the wall can provide a normal force. And the reason it's called the normal force is because in math, the word normal means perpendicular. So it's a perpendicular supporting force. People like to call it the natural force. It's the normal force. And don't get it confused with the net force either, all right? The normal force is a perpendicular supporting force when there is a surface supporting you. This guy is being supported by his chair, right? So you'll notice he has a gravitational force down of about 784 newtons. So he weighs a little bit more than a typical high school student, which would be about 600 newtons, which would be equivalent to about 150 pounds if you average all the guys and girls together, right? And then he's being acted upward with a normal force of 784 that's balancing that, so he's not accelerating because he's at rest on the first floor. Now, the purpose of this lab is that in the little Kami assignment, not this one, this one, all right, you're going to be comparing the different sensations that the rider feels with the actual forces, all right, and noticing which forces are bigger than others. So is the gravitational force bigger or is the normal force bigger? And you can see that in the picture. And also recording the value of the acceleration in meters per second squared. It's written a little funny here, but this is meters per second squared, and the direction. Okay, so let's go back to the simulation. So if you say go to floor 20, at first it kind of seems like nothing happens, but notice everything before we start, right? He's at rest at the first floor, we've got balanced forces, and we're going to ride to floor 20. Okay, now, in the beginning, you'll notice that the normal force gets bigger, okay? And he feels heavier. Then he feels normal for a while as the forces balance out. And then at the end of the ride, he starts to feel lighter as the normal force again gets smaller. Okay, let's repeat that ride and watch what happens in all three of those things, right? So notice what happens to the forces here, both the gravity force and the normal force. Notice how he feels, the feelings, the sensations the rider is feeling. All right, and again, and then also notice the acceleration that's way at the top. All right, and then similarly, you can then go on do the reverse trip, right? And so you'll notice again, the accelerations are written here. All right, the feelings are described here, and the forces are described there. And all of these will be recorded here, and then you're going to answer questions about them. Hope that helps.